So I've got one problem on the board right now, and I have a calculator in my hand. So the question is -3, -5 the solution to the system written here? Okay, remember, a solution to a system is written as an ordered pair. You're solving for both x and y, the x-y pair that works in both equations. So from the previous video, we know that it is the solution, right? But just to let you know, how could you do this problem? Right? It's a true-false problem. Well, if you are asked to show your work, you'd really have to plug in each ordered pair to both equations and make sure it works, right? You'd have to do 3 times x, so 3 times -3, minus 4 times -5 equals 11, and check that. Well, this is -9, and now it's plus 20, right? Negative times negative equals 11, and you got 11 equals 11. So it works in the top equation. And the bottom one, we have -3 for x equals 2 times y is -5 plus 7. Well, we get -3 equals -10 plus 7. We get -3 is -3. So that's the work that shows that it works in both equations. So because it works in both equations, yes, it is a solution. The answer is yes. Here's another way to do it, though, okay? And this is where the graphing comes into play. I'm going to show you this just once, okay? So with respect to graphing, oh, I'm cut off, aren't I? That's okay. With respect to graphing, you have two equations here, neither of which are in y equals form, right? For this calculator, you got to put the equations in y equals form. You don't have to be perfect about it, but for the top one, to solve this for y, to get y by itself, think about it, to get this term by itself, the y, we're always getting positive 1y by itself, we'd have to subtract 3x and then divide by the -4, right? We'd be taking away 3x and dividing by -4. So if we do that, we end up subtracting, so we have 11 minus 3x, that whole expression, and then divided by -4. This is what y equals, right? Well, I can get y over here, really, right? Y equals that. Okay? This is not pretty. It's not a pretty form of the equation. But that's all you got to type it in your calculator. If you're going to use your calculator, just to get y by itself, we'd be taking away 3x. So we have 11 minus 3x, and then dividing by -4. So make sure you parenthesize the 11 minus 3x, okay? Or, if you think about it like this, guys, you can write this in slope-intercept form, right? -3x over -4. A negative over a negative, it means the slope is 3/4, positive 3/4 x. And then 11 divided by -4, it's not pretty, but it's -11/4. So you could type in this guy also, all right? If you wanted to, if you really want to have it in y equals mx plus b form, which you don't have to, you could write y equals 3/4 or 0.75x minus 2.75, all right? But it's totally fine in your calculator if you just type in this. For the bottom one, I have y equals, see, parentheses, 11 minus 3x, and then over -4. The top one, if you do the other equation, if you solve this one for y, you'd be taking away 7 and then dividing by 2, right? Taking away 7 and then dividing by 2. So you get x minus 7 divided by 2. Again, if we wanted to, x minus 7 divided by 2, we would type in the calculator like this. But if we think about it the other way, x minus 7 over 2, you can write this in slope-intercept form. X over 2, it's like 1x over 2, right? So the slope is 1/2. 1/2 x minus 7/2. So you could type in that expression if you wanted to put it in mx plus b form. But you don't have to. You could just write it in parentheses like I did as x minus 7 over 2. So you have in both of these equations, right? Make sure both of the equal signs are highlighted. If they're not, just go over them and hit enter. Now, if you hit graph, that's what you get. And if you don't get that, just hit the zoom and then 6 to get to that main screen. All right, so that's that. And you know, they're both kind of similar slope, right? Because they're both kind of flat and they have a positive slope. Remember, the slope is 1/2 and this slope is 3/4. So they're kind of rising at a kind of a similar rate, right? Now, you can see on the graph that they meet in the third quadrant, right? We know the answer already was -3, -5. So that makes sense, right? The solution to the system was -3, -5, which is in the third quadrant. That's the point of intersection between the two lines. That's the point that's on both of these lines, right? It's hard to see that on the graph. You see which quadrant they intersect at, but you can't really tell exactly where they are. So one thing you could do is you could hit second and then table, that old table you have, right? Now, you see both y's in here, right? You have the x value and then both y's. Well, if you find which x value produces the same y value in both, that's the point of intersection, right? You can scroll up and down and you see, all right, so the point 0, negative 3.5 is on one graph, 0, negative 2.75 is the other one. That's just the y-intercept, right? But if you try to find where are the y's the same, well, you see it right here already, right? A negative 3 for x is negative 5 for y here and here, right? The other ones have different y values, negative 6.5, negative 7.25, whatever. But the point where y is negative 5 in both has an x of negative 3. That right there is the solution to the system, the point negative 3 comma negative 5. All right? Just kind of have to use your calculator to help you. Right? You can use your calculator. I mean, there are going to be problems where I ask you, okay, show this by elimination, show this by substitution. So you've got to show the algebra, like I showed you in the first video. But this is a cheat sheet, sort of, right? This, you know how to use the calculator, the tables in the calculator, you can see exactly where the intersection happens. All right? We will do more with the calculator in class. Okay? But I just wanted to go over that, just how you can use the table to find the solutions. All right? But remember, you do have to solve for y. If you're using the calculator, you have to get y by itself, which is kind of annoying in these problems, right? So if you know for this problem, it's probably just faster just to plug in negative 3 for x and negative 5 for y into both and make sure that it works, which it does, right? It did. You can always use the calculator also. All right? Now, the next part of this video is going to be to explain to you where some weird types of solutions could happen. All right? So this part we're going to deal with, we're going to tack on some more what we're calling need-to-knows. The need-to-knows of this unit are infinite solutions. When might you have infinite solutions to a system? And then when might you have no solution? Let's do no solution first. If you think about the solution to a system, the solution to a system of equations is the point of intersection, right? So if there's no solution to the system, that means the lines don't intersect. And when lines don't intersect, what must they be? Parallel, okay? There is no solution when the lines are parallel. When the lines do not meet, they are parallel. When, by the equation, do you know lines are parallel? When they have the same slope. So one example of a system of equations where there would be no solution is like y equals 2x minus 7 and y equals 2x plus 3. These are two lines. Both have the slope of positive 2. They have the same slope. They are going to be parallel lines. There will be no solution to the system because a solution is where the lines meet, and these don't meet. Okay? Now, how would that make sense algebraically? Well, these equations, in fact, both are in explicit form, right? So only one of them needs to be in explicit form to use substitution. If both, you definitely want to use substitution. So what we're going to do is to use substitution to solve this is we're going to replace, you could have done this with the other one, but I'm going to replace this y, right, y equals, with 2x plus 3. So we'll have a new equation, 2x plus 3, instead of y, equals 2x minus 7. Now let's try to solve this, right? Get the x's together, okay? So we're going to take away 2x. Oh, we get 0x, or 0, right? 0x, and we take away the 3, so we get negative 10. We get 0x, or 0 equals negative 10. Now, there are no variables left, right? That doesn't necessarily mean there's no solution. It usually does, but not always, all right? There's no variable, but we get a false statement. This is not true, right? 0 is not equal to negative 10. That's impossible. Because this is a false statement, we know there is no solution to the system, okay? So if you didn't see this at first, if you thought, all right, well, we have a y equals, let's just use substitution because we have explicit form, and you plug this in for y and you solved it, well, something weird happens, right? The variables disappear, the variables are gone, and you get a false statement. That's when you know there's no solution. So you might then go back and say, oh yeah, the lines were parallel. Of course there's going to be no solution. That's the only time there'll be no solution, guys, when the lines are parallel, okay? So that is an instance where there's no solution. do one more quick one with no solution. Let me give you one in, it's not so obvious. We'll do one in this form, 2x in standard form, plus 5y equals 10. And then let's say 4x plus 10y equals 20. No, that's not going to work. Sorry. Equals 40. That'll work. Okay. So here it might not be as obvious. The other ones were clearly parallel lines, right? Here, because we have something that's not in explicit form, we want to use elimination. So let's say we want to eliminate the x's, right? Well, we would multiply the top equation by -2, right? So that when we add the two equations, the x's will drop out. So multiply the equations by -2, add them up. -2 times 2x is -4x plus 4x is 0, so 0x. -2 times, so we get -10y plus 10y. We get another 0. We have 0x and 0y equals, that's -20. -20 plus 40 is 20. So we get an equation that says 0 equals 20. So once again, we solve this using a method that seems reasonable to us based on the format, right? Elimination seems reasonable because we have standard form equations. But then we get a false statement. 0 is not equal to 20. So this means that there's no solution. You have to write that. That is your solution. That's your answer. If there's no solution, guys, you got to write those words, right? Otherwise, it's going to be an ordered pair. So your final answer is either going to be an ordered pair, the words no solution, or the words infinite solutions, okay? And again, no solution, which means if we did try to graph these, they would be parallel, all right? They would have the same slope. Infinite solutions, okay? So we know no solution, lines are parallel. Infinite solutions, well, if lines have infinite solutions to their system of equations, right, that means that at more than one point on the lines are they intersecting. Well, how can you intersect lines at more than one point? Well, they're only going to meet once, right, if they're going to meet at all. Now, if they're the exact same line, it's kind of confusing. But if two equations represent the exact same line, that's only when you would have infinite solutions. If two lines are really on top of each other, that means that they are always intersecting. So every point on each line is a system, is a solution to the system, right? So this is if the lines themselves are the same line. Now, how could the same line have different equations? Well, let's just take y equals, let's put one in explicit form. Y equals, let's say 1/3 x minus 5. And let's say 3y equals x minus 15. What I've done, I know I purposely did this. I don't know if you know this, but I wrote down some equation, and I multiplied every term by 3, or by 4, or by 2, or by whatever, by some constant, all right? You'll get the same line. Okay, this will be the same exact line. So if we try to solve this, we might want to use substitution because we have y equals, right? We have y equals this stuff, not this form, but something like this. So let's replace the y with this, with 1/3 x minus 5. We got a new equation. It says 3 times 1/3 x minus 5. Right? Instead of y, we replace it with this stuff. Equals x minus 15. Well, 3 times 1/3. 3 times 1/3 is 3 over 3, which is 1, right? 1x minus 3 times 5 is 15 equals x minus 15. Well, we have x minus 15 equals, I mean, even if you kept trying to solve this, right, like you take away x, you get 0. You add 15, you would get 0. 0 equals 0, right? From here you can see they're the exact same thing on both sides. So no matter what x is, if x is 5, we get -10 equals -10. If x is 20, we get 5 equals 5. If you try to solve for x, they drop out, you get 0 equals 0. This is a true statement, right? You end up with something that's true. Whereas with no solution, the variables dropped out, and we ended up with a false statement. With infinite solutions, this is a long video, isn't it? With infinite solutions, the variables drop out, and we're left with a true statement. So a true statement means there are infinite solutions, okay? Infinite solutions. In both cases, the variable drops out.